Hi guys, there was a couple of questions from section one from section 3.1. This is from section 3.1, and the question was number 23. So before I answer this question, let me just quickly, I'm sure if you read the section, there are two different forms. These are called quadratic functions, and the two forms, of course, are a standard form and general form. Obviously, the most important difference is the way you find the vertex, which is the most important information for these functions. Actually, most of the time, once you find the vertex, the rest of the question can be answered very easily, okay? So this is the one we call a standard form. If you look into your textbook, I'm sure you already read this one. So this is when the function has this form, which is usually the most convenient form. So it's a times x minus h squared plus k. So anytime your quadratic function has this form, we call that a standard form. Now the good thing about the standard form is that the vertex, which is the most important information, should be right in front of you. So anytime your function is in this form, we say the vertex is h. Whatever the h is, that's your x coordinate. And of course, k will be your y coordinate, okay? And this is your vertex. But it has to be exactly in that form. And now once you have the vertex, the sign of a, as I'm sure, again, you saw in the section, if a is positive, the number in front. If it's positive, the parabola opens up. If a is negative, it opens down, okay? So please make sure you read the section carefully. All these facts are there. So in our problem, I'm just going to go ahead and put it up here, number 23. If you look at it very carefully, it's actually almost in a standard form. So we have f of x equals to x minus 2 squared. Okay, so as you can see, the only thing is missing is the k. So you already have x minus 2 squared. Of course, your a can be taken to be 1. So if there's nothing in front, there's always 1. So of course, we are missing the k. So obviously, just to adjust this, we can always add a 0. It's not going to change the function, but it does give us the k. So based on this so-called standard form, we can see our vertex in this case, for this problem 23, will be simply the h, which in this case, of course, is 2 if you compare that to a standard form. So your h is 2, and of course your k would be 0 in this case, okay? So there is your vertex. Now it's going to open up because the a is 1 in this case. As you can see, there is nothing in front, which means the number is 1. So it is positive, so it's going to open up. So actually at this stage, I suggest you graph it because the graph can help you to answer the rest of the questions, okay? So let me go ahead and just put the vertex here, and then we'll graph it and then answer the rest of the questions. So vertex is 2, 0 for this problem, okay? So let me just take this off real quick. So make sure you review the standard form for quadratic function, because there is another form called general form. So, but right now, this is of course in standard, almost a standard form. So now it's going to open up. So it's going to open up because the a is positive. So I suggest you graph it right now because the graph can help you with the rest of the information. So your vertex is 2, 0. And it opens up. So there is your parabola representing the graph of this function. So the axis always means the vertical line that passes through your vertex. So as you know, vertical line always has the equation x equals to a constant because it crosses through 2. It gives you x equals to 2. So that is your equation for your axis. And that's the first information you get from your vertex, right? Because remember, the 2 is your x coordinate. Now, domain, the good thing about domain of every quadratic function, not every function, but every quadratic function, which is all we deal with in this section, is always going to be all real numbers. So domain is always the same for every quadratic function. Now, the range depends on the function. So the range, of course, I think I can squeeze it here, is going to be the y values. Remember, domain of the x values. Of course, all the real numbers are in your domain, but the range is the y value. So this one, it starts from 0. Y value of 0 goes up forever, which means basically it's going to be bracket 0 to infinity, which is all real numbers greater or equal to 0. Okay, so that will be your range. 0 to infinity, because the y values start from 0 and it goes up. Now, since when the graph goes down, the function is decreasing, and when it goes up, it's increasing. So as you can see to the left of 2, it's always going to be go down. So we say, let me actually put it up here. So we say that decreasing from negative infinity, because as you come from left to right, it's always going to go down, down, down until you get to 2. So we write that as negative infinity to 2, always everything in interval notation. And then once you get to 2, it starts going up. So we say increasing on 2 forever, of course, which is infinity. So 2 to infinity is where it's going to be increasing. Okay, so I hope now you see why I told you the graph, the function does help us with rest that information. So always, once you know the vertex, you know how it opens, always graph. So the graph can help you with the axis, domain. Well, domain is of course all real numbers. The range depends on the graph, and also increasing, decreasing. Okay, so let me go ahead and stop this one, and then I'll make another video for another problem in section 2.8, number 81.